Welcome to Stemiverse podcast episode 45. In this episode, Peter and Marcus talk with Sanjin Dedic. Sanjin has a bachelor's in Mechatronic Systems, majoring in Robotics and Computer Vision, and spent several years working in the industry as an engineer. He then retrained as a teacher and taught systems engineering and digital technologies at secondary level. Recently, he's been developing a series of technology programs for G.A.T.E.WAYS, gifted and talented education, covering everything from coding to robotics to applied mathematics and microcontrollers. These programs have been delivered to students in Melbourne, Sydney, Canberra, and Queensland. As head of eLearning at Techxellent, he has combined his technological expertise with his educational experience to create innovative teacher training programs and resources. This is Stemiverse podcast episode 45. Stemiverse is a podcast produced by Tech Explorations. Our mission is to help educators become awesome at teaching STEM, be it at home or in the classroom. Whether you are a professional or casual teacher teaching in a classroom or a parent or caretaker teaching at home, this podcast brings you the knowledge and experiences of practitioners, academics, entrepreneurs, and lifelong learners who are passionate about education and strive every day to help our children prepare for life in a world of radical change and, why not, abundance. Marcus,
Peter,
you're back in the lab.
I am. It's been too long.
I haven't seen you for a while. What's been happening?
What has been happening? We've had EduTech.
Yes. Feels like a million years, maybe a million years ago. It's been a long time.
EduTech. What else? I've been taking a few weeks off for a special project.
Yes, top secret. We're not telling anybody about that. No.
What else?
What's happening in England? So you're going to England next week?
On Sunday, so today is Friday.
Yeah.
And we'll be doing the meet and greets and saying hello to people and seeing where they make the Raspberry Pis and all that stuff. Wow. So that should be fun.
Take lots of photos.
Yes.
Yeah, I know that's... there are secrets, so that they're not actually allowing you to take video.
Yeah,
top secret.
We'll see what we can get away with. I think Sony does have some guidelines. Something like there's only allowed to be small groups at a time.
Sony is a manufacturer for the Raspberry Pi?
Yes.
In England, right?
England. Yeah. Well, in Wales, actually. So they make a distinction between the two over there.
It's a different country.
Yes, totally.
Well, it's going to be an awesome experience.
Yeah, it should be great.
Are there going to be any workshops, any training?
They haven't specified exactly what's there, although they have sessions.
Right.
It's like going to a conference where everything is a mystery. There's 2 days of sessions and 3 sessions per day. So that'll be interesting.
So that's going to be over 2 days, but you're staying over in Wales a little longer?
So flying over Sunday, don't have to bore the audience with this. Arriving in on Monday, going straight to the conference on the Monday, and doing that for Monday, Tuesday, and then it's a little bit happening on Wednesday, and then coming back to Australia.
That sounds really hard work. Yes, sounds really hard work. Well, enjoy. And when you're back, we'll do a special one and you can tell us what you saw.
I will let you know all the secrets.
But speaking about EduTech, who did we meet at EduTech? There were a few people, but there was one in particular.
Well, are you trying to do a segue, or are we going to talk about all the audience members that came up and said how wonderful Peter is?
Oh, no, come. No, definitely not. Let's talk about Sanjin, who's been waiting very patiently the other side of the line, or the internet, really. Mm-hmm. And so we met Sanjin there.
Yes.
Hey, Sanjin, how are you?
Pretty good, guys.
Thanks for waiting.
It's all good. Interesting discussion about, the Raspberry Pi factory.
Yeah.
Get as much info as you can. I'd be curious about a few things myself.
Yes.
It's the Sony.
Yes.
Sony, yeah.
I think everything is covered under our NDA. But hopefully they'll say stuff that's... You can talk about this. I'm hoping that it's mostly teacher-type training or educator training.
Yeah.
Rather than just here's how to sell a Raspberry Pi.
Exactly, yeah. I think it's going to be a lot of education in there. Mm-hmm. That's what the Raspberry Pi Foundation is all about.
Yes.
But hey, this episode is not about the Raspberry Pi or Sony. It's about Sanjin, who we met, a couple of weeks now ago at EduTech. We had a discussion there, and I thought he's an amazing person to have on our podcast because of what he does. So how about we give Sanjin a opportunity to talk about his background and what he does, and then we'll talk about a lot of interesting things. Take it away, Sanjin. Tell us who you are.
Oh, all right. I don't know, a brief life story. I'm originally from Bosnia, but I had lived in Libya under Gaddafi's rule for about 8 years before coming to Australia. My parents worked in the oil company.
Awesome.
The what company?
Oil.
In the oil industry.
Actually,
my dad built the man-made river. He worked on the man-made river project in Libya, which is like those giant pipes.
How old were you? Do you remember life in Libya during Gaddafi?
Yeah. I do pretty well, actually.
Okay. I think maybe we'll talk a little bit about that as well. It's not exactly education.
Okay, I mean, I'll continue to the educational technology track. So after year 12, I came to Australia. I did Mechatronic Systems at ANU, which was, one of the fairly early robotics degrees in Australia. And then I worked as a mechanical design engineer for they were a pump company. We mostly did mine dewatering systems. So basically for 5 years, I was developing solutions to figure out how to get, millions of liters of water from the bottom of mines to the top in the cheapest way possible with certain constraints. So that was a lot of fun, but I kind of got tired of it after 5 years, and they were giving out scholarships to get a teaching qualifications like crazy. And that was, I think, about 2012. So I decided to try that out. And I got into teaching. I taught for 1 year at secondary, and then other opportunities opened up. So I ended up doing gifted workshops for an organization called G.A.T.E.WAYS. And as, we're in a field where expertise, people that have an educational background and real technical expertise and this type of stuff are relatively rare. I am now doing teacher training for a number of organizations like Digital Teaching and Learning, DLTV here in Victoria, Critical Agendas, TTA over there in Sydney. So I'll be over there in, I think, September 6th, something like that. And so, I live my life developing curriculum, basically, testing it out on gifted kids, basically around the country, turning that into teacher resources, and then also doing some consulting with schools.
Great. Create content. It's a very hard job.
Well, we like him because of what he does. I thought, that's not self-serving.
No, it's really a hard job, like writing good curriculum. So, so your background is in mechatronics. You've been an engineer in the mining industry. You decided to go into education.
What did you do, mechatronics?
First of all, my dream was to become a professional tennis player, and being an engineer was, if in case I fail at that particular endeavor. Yep. And I thought, I was pretty good at maths and pretty practical, mechanical. I was obsessed with Lego my whole life, and out of all the engineering degrees, this one sounded the most, how do I put it? The most adventurous technically. And that not a lot of thought went into that decision, but it just kind of seemed the coolest sounding thing out there, majoring in robotics and computer vision. So that's kind of why I picked it.
The badge is important.
And sorry, what year was this?
So I started in 2003 and graduated in 2007. Okay,
so at that time, what were you using? You wouldn't have been using Arduinos.
Oh, technology, right?
That would have been Pixel.
I honestly don't even know. Like we had microcontrollers and breadboards and we did even machine language, but we used a lot of MATLAB. So a lot of control systems with MATLAB and computer vision. I think we also used MATLAB to sort of analyze images, count colors of pixels, and then kind of write algorithms that recognize objects. So I think MATLAB sticks out more than anything else. But there was, for object-oriented programming, we did something called Eiffel, You'd have to Google that.
Yep.
And most people don't know about it, but apparently this creator of Eiffel was one of the pioneers of object-oriented programming. Mm-hmm. And the language has built-in structural integrity such that it's really hard to write bad programs.
Yep.
But, imagine doing that as your first ever life experience in programming. It was pretty crazy.
Yeah, they did something similar to that for us. So I did Mechatronics. I did not finish.
He's a dropout.
I'm a
proud dropout.
Dropout. No, I hacked the system, damn it.
I wish it was a dropout, actually, seriously.
Being a dropout, is it's a very high level thing. Apparently, every Silicon Valley billionaire has to drop out before they graduate. Otherwise, it must be bad luck or something. So I think, Marcus, you're in good company there.
I've got to clarify. I think being a dropout at that level, especially, indicates that you really have strong convictions about what really you want to be able to do, and you're prepared to perhaps upset a few people in order to do that.
No, I was doing a postgraduate degree at the same time. I hacked the system. So I have a master's without a bachelor's. So I just thought, this is way more interesting. Anyway,
that is very interesting. You got a bachelor's, so master's without a bachelor's.
To be honest, I don't know how your guys' university was, but personally, I felt like this is like not teaching me engineering in a very practical sense at all. I felt like it was just a 4-year-long test of IQ and work ethic. You're just going to throw really thick books and complex problems at you. And if you survive, then we'll give you this piece of paper, and people are going to trust that you can learn stuff fast enough to pick it up. But that was kind of my impression of doing engineering at ANU. It was
I feel the same.
Very, very hectic.
I did engineering. I understand the difference between academia and the outside world. I think they're complementary to each other. I think you can have one and not the other. So I felt like that when I finished my engineering degree, that I knew a lot of stuff, but I didn't know how to put them together in something real, build something. So the first few years after university was all about that. It was all about applying and putting to practice what I learned by reading textbooks the 4-5 previous years.
And to be fair, the thing did actually, was beneficial in a couple of ways. Like when I was at my work, I was like the only person volunteering for crazy projects. Like when, I don't know, we had to pump something called, you guys know what a non-Newtonian fluid is?
Non-Newtonian, like
it's like Kuklek,
Yeah.
And basically, technically, it turns into a rock, and most pumps look like fans, so it just breaks pumps like crazy. And we wanted to offer that, and nobody wanted to do it. And I'm like, yeah, sounds like fun. So you sort of get an attitude. You get an attitude of I don't know. It's not just can do, but there's a certain excitement to higher level technical problems that you get out of it, and also what you get out of it, I suppose, is a realization that at one of the better universities in the country, I mean, this stuff is not taught very well on average. Maybe it is today, but when I was there, as I said, like there were kids arriving for the first time in their life writing a line of code. Mm-hmm. And I had like 150 lines of code assessment in object-oriented programming within 6 days. Mm-hmm. To mention what a mission impossible that is it's kind of crazy.
They certainly did that to us as well. I can distinctly remember, you have to build this algorithm, and for this one, it had to be in C. And they didn't even show us how you compile in C. Just like, here's all like the theoretical, how you do the algorithms and what have you, and they give you the pseudocode, but there's no.
But hang on, you did have Google, right?
Yeah, but back then we didn't have the resources of Stack Overflow. We had like the BS Expert Exchange that they show
which
one
actually
thing.
You had to pay for that.
Yeah, they show one thing to Google. Yeah, and then when you actually hit up the
$10
site,
for an answer.
And the answers were rubbish.
Hey, Sanjin, let's take our conversation further and try to uncover some educational gems from this conversation. So I'd like to ask you, like, you've got your industrial experience in the mining industry in Australia, pretty advanced stuff. and then you decide to move into education and write curricula. So I'm curious, how did you carry your experiences and your knowledge from one sector into the other? And if you feel that there has been an influence?
That's a good question. To be honest, I hadn't thought about it much, but I would definitely say there was. I'll give you one example. So, like, I go into schools and they have STEM programs and they ask me, well, what do you think of these? And generally, you know, with teachers, you have to be very complimentary and nice before you give any criticism. But the reality is in schools, there's such a stress on things that you can measure, like documentation. Kids spend 6 months on a project that doesn't work, and then they have 100 pages of prettily arranged documents. And I kind of just sort of move them in a direction saying, look, you know, first you got to prove that something works. You got to build something that at least in the lab is going to hold together for more than 10 minutes to prove that a product can be a product. At that point, you can think about, you know, documenting why it works and how other people can build it and how it can be systematized and improved. So I think that's kind of one random example.
Right. Sorry to interrupt you. So if I understand right, what you took from the industry was that you documented things that actually did work in order to allow others to understand how it worked and then to take it further, improve in the future, etc. Whereas typically what you see in education is that documentation is one of the things that are done because that's how it's always been done, right? Not specifically document something.
There's also just this attitude of like, it has to work in the real world being goal number one. And I don't think that should be true just for industry. I think that, you know, if you're going to build a circuit prototype of something, the journey of actually working, optimizing, and documenting it only becomes relevant after you've built something that shows enough promise that it's going to work. So I think I've been helping schools move a little bit more in that direction, and I use the term minimum viable product. That's kind of a very popular Silicon Valley term, but I think that is really the first stage of engineering development.
So tell us more about the MVP. What is it? Why is it important?
Well, the idea is that, let's say you have a plan to have a product that is going to do A, B, C, D, E, F, G. Well, if you identify the most important aspects, and maybe they're A and C, you go about, well, what is the simplest thing that we can build that has those attributes that can get feedback? Now, for Silicon Valley, it's feedback from the market. It is seeing whether consumers like it. And then, you know, from that point on, they invest more heavily in projects. They get in and develop them further. But in terms of, you know, what I did professionally, you know, for example, we have a pump that we want to move under a certain price point, which means that certain parts that are metal now have to be made out of plastic. Well, the minimum viable product is you make the strongest possible plastic part, meaning you use as much plastic as possible. You buy the strongest one and you put it through a set of tests. And if it fails any of them, then this is, then this is a pipe dream, right? So you go to a catalog, you select the strongest possible variation of plastic. And if that's not good enough, there's no point taking that process any further. So you kind of devise a first experiment that is going to reveal how promising a particular course of action is. In this case, replacing this particular metal part with a plastic one.
It's, I think people may be familiar with the minimal viable product and tests that companies like Dropbox, for example, have implemented. Do you know that story?
Oh, okay. I don't know the Dropbox example. So
I'll give you the quick version of the story, because that is going to help, I think, our listeners to understand what an MVP is, not just in engineering, but in business and pretty much any aspect of life. So the founder of Dropbox had this idea of making it possible for files that sit and live in different computers and devices like smartphones to be able to really easily, transparently synchronize between them, so that when a person that owns a Word document, for example, on one computer makes a change, it Word document and the same change is reflected automatically without the person having to do anything on all other computers. So instead of going down, sitting down on his computer and starting to write the software that would support this kind of functionality, he just took a bit of paper and started drawing on the paper what the user interface would look like, what would happen if the user makes a change to one file that was on just a dummy piece of paper, and there would be another piece of paper that represented the result of that action on another computer. So we play around with pieces of paper and describe the process to his friends, and that paper-based version of Dropbox was the minimal viable product because it indicated that people.
That's the definition of MVP. Keep on going.
No, I'd like to hear yours as well. But that's a story of how Dropbox began, at least as a proof of concept of whether people would be interested in this kind of product. Because before that, people used to use things like FTP, where they would have one single repository for all the codes, and all the computers would upload and download constantly files from that single location. So what's your definition or example, Marcus?
So when I think about MVP, it's more about the minimum feature set that is required to support a product. So the great example is the companies that, say that they have some AI or magic system black box that's going to do something where in reality it's the founders busily doing things by hand in a non-scalable way behind the scenes, and they find out what the customers actually want, and then based on that they go and build the features for real. So it might be working out of a spreadsheet to begin with behind the scenes, and then ultimately building the web application or hardware or whatever it is.
And this whole company is being built on those MVP principles, where
MVP and lean startup.
Like imagine before you had Google automatically like aggregating their knowledge of the world. I'm exaggerating here a little bit, but imagine that behind Google there's a bunch of people. So you put your search term in the Google field and you think that everything is happening automatically in the background, but actually you've got a guy there, could be monkeys.
Well, there was.
Putting this together.
There were literally web search companies that were based off this. One that comes to mind was Mahalo by Jason Calacanis, and they would literally have agents sitting humans
doing the work
initially,
users would perceive were automatic,
and then they would eventually the computer took over, but that's how they started,
right?
And he pivoted.
It is a concept that has saved a lot of work.
Well, one thing that I would say, like the commonality between everything that we said, is finding the smallest possible amount of work you can get to get really valuable real world feedback on something that your final product will be. And I guess, in engineering, I never use the term minimum viable product, but I do use it in education because, people love the new Silicon Valley lingo. And it really paints a correct picture of what it is that you should be trying to do. I mean, you should be trying to prove that something A works and B is showing itself to be somewhat useful before you go through the long journey of trying to make it into a finished product.
What are some of the applications of the minimal viable product in education? Either perhaps, in your case, you are a curriculum designer. What if you're a teacher? For example, like designing a curriculum, how can you apply these principles?
Okay, so I'll give you a really short story with a school that I worked with, Northside Christian College. So I was only with them for 4 sessions, but this whole thing was 10 double sessions, and then they continued on with their teacher. And they had the subject is called innovation. They had been doing it for years, and basically it's exactly the standard type. Kids spend 85% of their time writing reports on something that probably doesn't work. So I asked them to do a concept design on one sheet, one paper this was after doing about 5 hours of Arduino. We've just gone through the basics and used 10 sensors. And I just said, okay, other than the tools that we use, you can introduce only one new sensor or actuator, and you should propose a product, and everything about that product should fit on a page. At which point we're going to order it, and you're going to build a prototype. So with those massive constraints, I mean, the kids had to use stuff that they already knew how to use because they had done the tutorials. They'd already done basic, button activated circuits. So we did some reaction time. We blinked LEDs. We tripped a relay to start a fan. And with those tools, they developed things like, one was a low power battery operated Arduino that was going to be in a fridge that was going to raise an alarm if the fridge ever raised above a certain temperature. So it had a temperature sensor. This kid actually lived rurally, and they had lost a fridge worth of meat twice in the last 10 years. And this would be kind of useful for them. The other one was a UV sensor on the roof of the school that tripped a relay that had an alarm when the UV index went outside of a certain range. And another one was an attempt at a lie detector. So one of the sensors that we had used was a heart rate sensor by DF Robot. And this kid also heard that if you combine a heart rate sensor with a skin conductivity sensor, then you have, a lie detector test. So they had basically all within our 4 sessions together built a working prototype, which then they continued with in their remaining sessions. And the way this would have looked otherwise would have been that, the step of having something that works is an ambition that may or may not be fulfilled. Whereas, as an engineer, I think that is the first step. Unless you have a prototype that has some value, then you should spend the rest of your time, no matter how much time you have allocated, to building such a prototype. Because, writing imaginary reports and imaginary things that might just work is useless, pointless. I mean, we've probably all done that at university, but if there is something that I'd like to change in engineering education, it is that precisely. Like, unless you have a prototype, you might as well write a fictional book because...
Well, are you saying that reports should be abolished, or perhaps maybe balancing them better with results?
Oh, no, I'm not saying that reports should be abolished. I'm saying the report is something that comes after a prototype that works reasonably well. Yeah. Even in education. And that the project, let's say we have 10 weeks together, you're going to get as much of this done. You're going to build a prototype. You're going to then write a small report on that prototype if it works, and then you're going to optimize it and report on those optimizations. You document it sufficiently for other people to replicate it. But let's say you can't build that prototype. Well, maybe you should try building another one, because writing reports on something that just doesn't work is not fun for the student, and it's not the best use of their time. You get my point.
Yeah, I suppose you can learn from things that don't work. I learn a lot all the time because I do make things that don't work.
You can learn a lot from things that work half the time or work, in a suboptimal way, but, not work at all. It's a different category altogether.
Sanjin, I wanted to ask you about just a little bit more emphasis on reports. What do you think that a good report should be like or should contain? And I'm thinking that now, being in the 21st century, we have a lot of ways to communicate with other people, whereas back in my days with university, you had to print it out on paper, actually maybe type it on paper and hand it over to your supervisor, who'd be the only person looking at it. Should we be taking more advantage of what communication is like today in the context of schools and universities?
Well, I think that, first of all, I tell the students even once that attend my engineering classes that persuasive speech is probably the most useful skill set in the whole world. So I think that if they build something, they should first of all have a rationale for why they did it. I mean, why it's interesting, why it's useful, why it made them excited. They should answer all the whys, and that should be present in their presentation or report. Secondly, they should think on a practical level, what information is essential in order for this to be replicated. I mean, we're dealing, with programs and circuitry. So if they did something interesting, it's just like we have Instructables or Hackster.io, the same principles apply. You want to put down the essential information for this to be replicated. So, a schematic that other students and teacher can understand, the code, which is commented and not just commented, but rationalized. I did this because, and that because, that because. And finally, it should include maybe a wider, more grand visions of implications of what would it mean if we built this into something industrial and perhaps, more
like talk about the future, perhaps potential ideas for improvements. What about the media that we use? Like, as I said, in my days, we used to use paper. Now there's multimedia, like should you make a video, for example? Should you talk about it in your Facebook group? Or should we students put the code on GitHub, for example, share the code with the world, essentially, not just the class?
Yeah, I think videos are a valuable tool for teaching, and also to sort of demonstrate that an outcome was reached, right? Because you know how temperamental and sensitive gadgets and electronic devices can be. They work 1 minute and the next thing they're up in smoke. So actually recording that progress is definitely a good idea. And I do advise that to students. And I mean, animated presentations. Have you ever used Prezi before? P-R-E-Z-Y.
Bulgarian.
Yeah. Those are pretty cool. And also, I think I'm a bit old school when it comes to electronics. I like kids to actually draw schematics and just use something like TinyCAD. But I think in terms of their own understanding and their own documentation, using a tool like Tinkercad. Have you ever drawn circuits with that?
Yes, I have.
Yeah.
It's great.
I think that's pretty awesome and clearly conveying information for sure.
Yeah, Tinkercad allows you to simulate as well, doesn't it? So that you can play with circuits in software.
That's right.
Speeds up
this
tinkering aspect of learning.
And I mean, imagine as a teacher, if that's what it is that you're marking, that's a lot easier, than getting a bunch of, jumbled wires or like a breadboard circuit that you're not sure what's meant to go where and you're trying to follow a schematic. If they actually had documented it in Tinkercad and given it to you, you can press play, see what it does, read the code, and you can have a very clear idea about what it is that the students did in much less time than in a traditional way, I suppose.
In my bootcamp, I encourage students to keep notes on paper. So as you're working on a circuit, even on the breadboard, just have pen and pencil or paper. Sorry, just have, you know what I mean, pen and paper, and just scribble down what you're doing, and that helps you because people forget, especially when you get started. You try to remember: did I put the LED in this orientation or the other orientation? I can't remember why and which way I did it, but you can just scribble it down. So taking notes is an essential part of learning, especially in the beginning.
And I think it should be also like this is. Trust me when I say this. I teach a great many groups for the first time in this field. I think kids have different ways of documenting what they do. So I generally leave it open-ended, but say, hey, what you're doing is pretty interesting. There's going to be files. If you don't have a USB, you should email those to yourself. If you've got your phone here, you can take videos. If you want to draw diagrams of it, those are my personal favorites. But if you want to take notes of any description, keeping track of that when you revise and being able to see your own notes on a particular subject, especially I know that you do online courses. I think revising something where you can go back to that lesson, where you have your own notes for it, and I guess your own prototype programs of it is going to work a lot better than just going back to it as if you're going back to that particular chapter in a textbook.
So do you have a preferred electronics kit to teach from?
Oh yeah. Arduino 0 to hero.
That's a good one.
So I've been using Arduino with students since I started teaching at the start of 2013. I bought my own students an Arduino kit with my own money because the school I was working for had already spent their whole technology budget. And I had actually been buying stuff from, eBay and Banggood and using that because they were cheaper. And until one day I got hired to do a mini curriculum for a school that was using the Robot kits, which I actually really liked. And I ended up getting in touch with the Robot and we ended up making a kit together, which incorporated all of my favorite tutorials that I created over the years. So it's called Arduino 0 to Hero, and it comes together with an online course. So by all means, Google that, and you can get it at Marcus's Little Bird Electronics.
I hear they're also a good store too.
Yeah, highly recommend
it.
So can you tell us about that process of making the kit?
The process and the outcome. So what do you learn from the kit or with the kit?
Well, okay. So, first of all, I just thought that I wanted to do something that I haven't seen done in many other sort of online Arduino courses. It's that to take a slightly slower start than most people do, because the clients I always imagined for this kit would be schools and students, a lot of students doing it for the first time. So they do a whole module on just building circuits. So they don't write a single line of code, and all they got to figure out initially is what a schematic is and how to represent that on a breadboard. And they actually build a circuit, and usually they have a couple of challenges to play around. So basically, the pedagogy of it is about 50% following a set of instructions given by the online course, and about 50% is subsequent troubleshooting. And it's systematic in that they start with just circuits. Then they do just simple digital sensors like a button or a PIR, just a simple on and off. Then they do analog sensors, which have, values 0 to 1023. Then they use sensor libraries. And finally, they build more advanced circuits and applications. There's a memory training game in there. There's a guess a number game with the 7-segment display. And there's some fairly advanced concepts with gyro and accelerometer visualizations using a software called processing. Have you ever?
Yeah.
It's one of the originals.
Back in the day. Is that still used?
Oh, yeah.
Sorry, I'll rephrase that. Are you using processing on the desktop or are you using processing.js?
I just went to processing.org.
Okay, so the old school processing.
And I looked at their code examples in terms of visually representing the serial output. So I think it's a Windows installation.
So what is processing, Sanjin? Could you describe what processing is for our audience, please?
So processing is a software that uses a C Java-like programming language that represents, basically it's like a visual output. You generate a screen, you draw on it, and it's quite convenient to have your sensor outputs displayed in a visual manner. So for example, if you were trying to make something like a Segway, you could map how much power you want to be giving to the motors to stabilize it and how far off center you are at present. So it's a very good way to visualize outputs of a microcontroller. And other than that, it's kind of famous in the world because people have done a lot of fractals. They've generated a lot of fractal geometry with it and with a fairly high amount of detail. So I imagine that, processing would be a bit like Turtle, except that it's a lot faster and more efficient. Have you ever used Turtle with, it's like the original logo?
Yeah, when I was 15, I think. Yes. My Apple IIe.
Yeah. So, I mean, if you know what logo is, really, processing, you would take the turtle away and you would literally be drawing pixel by pixel, but processing would be something that's a lot more dynamic and efficient, but does very similar things.
Processing is to programming what Arduino is to electronics.
Yeah.
So processing was designed for artists and designers to be able to create visualizations without needing to know too much programming. And the programming that they did need to know was pretty simple. And that's pretty much the same ethos as the Arduino, to make electronics and making accessible to those who don't necessarily, have an embedded firmware background.
And in fact, the interface and the syntax is very similar to Arduino. Like if you use Arduino, getting to use processing is not going to take too much effort.
I actually believe that the IDEs were a fork of each other.
Okay, there you go.
Deceptively similar,
Yeah, they
right?
are.
Some people get confused. They think that processing is Arduino for the desktop, but it's something separate.
To be fair, processing, I believe, was Java back in the day. And,
Still is Java.
A cut-down version of Java, similar to how Arduino is a cut-down version of C++. Whilst you can do C++ in the IDE if you want to, it does take away the rough edges of having to do C++.
I should also mention that I also use processing, and the way by which I use processing as an Arduino person is I connect my Arduino to my computer via the USB serial port, and then I can send data from the Arduino's sensors to my processing script, and then the script will visualize the data into bar graphs, for example, and create some interesting user interfaces, which is a very common way to use the processing with the Arduino, isn't it, Sanjin?
Yeah.
It's like to visualize sensor data from the Arduino onto the desktop. It's something that people tend to do quite a bit with processing.
Yeah, with the advent of web serial or web USB.
You can do it wirelessly.
I think, you can actually just plug it in and Chrome will detect your Arduino or your serial, and you can pump data straight in that way. And I think that is really lowering the barrier for a lot of people.
Yeah. Have you guys used much of the sort of, in-browser Arduino? Because I've tried it out, and when it just came out, it was really bad. I don't know if it's probably getting better.
In the past for teaching, I've used CodeBender, which was another Greek technology by Vasily.
It's the first similar, the first cloud interface for programming the Arduino.
So they use
some more.
Yeah, I heard of that. That's like one school didn't have proper laptops; they had Chrome pads, and that was the only thing that you could. Sorry, what do you call them?
Yeah,
Chromebooks.
Chromebooks. Yeah, I mean, I hate them so much. I didn't bother learning the names, but so you had to. CodeBender was one way that you could use Arduino with a Chromebook.
So unfortunately, the API. What do I call it? NACL, so native Chrome libraries, that's being deprecated in favor of web USB. So in the past, you had to install a plugin for CodeBender if you wanted to work in Chrome, and now it's just built. These technologies are built into Chrome. So I think there's going to be a lot of stuff happening soon.
I like the desktop because of the speed. Like I don't want any lag when it comes to compiling and uploading. Because my compilation, recompilation, re-uploading cycles are very quick. Like I will change one letter literally and recompile. And
look, guys, honestly, we're doing this the old way. The new way is the BBC microbit, MicroPython type of way, where you're actually running essentially an interpreted language on the device. So,
The only tricky thing is, I believe that microbit will be able to do this with Chrome, but at the moment, by the standard way of putting those programs in, you don't get to see the sensor readings for the microbits.
You can look. There's no reason why they can't do that.
I'm sure it's coming. It's coming. Like there's a lot of momentum behind it.
You could just pump it out via serial.
I'm sure that's coming.
So all these technologies tend to confuse me. Like a few years ago, we only had Arduino IDE version 1.03, and that it would stay like that for 6 months, right? Now we've got a new version like every couple of weeks. We've got all these cloud compilers and capabilities. We've got different technologies like the microbit coming out with 2 different or 3 different ways to program it. So a lot of very confusing technologies and capabilities and processors. Now, you, Sanjin, as an educator who are also responsible for creating curriculum, probably have a method or like a system for simplifying all that and putting it into order that can allow people with different levels of capability, different knowledge and backgrounds to learn efficiently, which is very important. Like we're in a hurry, constantly including students. What, in your opinion, what makes a good curriculum? What are some of the attributes, and in particular STEM curriculum?
Okay, what makes a good curriculum? Okay, I'll give you examples of stuff I've created and I'll tell you why I think they're kind of cool. So, first of all, you're kind of aiming at, I would say, 3 or 4 key criteria. Well, I guess let's start with the curriculum that you have to meet, the Australian Digital Technologies curriculum. So teachers, first of all, want to know that what your content is, what your learning sequence is, meets that. Students, on the other hand, want something that is genuinely interesting and exciting. And finally, beyond actually ticking all the boxes for the teacher, something that's exciting, what you want is a learning sequence that develops slowly, taking one concept at a time that students get to put in practice and build on and build on. And doing all these 3 together is quite a challenge. There are certain general principles. So I would say that if you're doing something like Arduino, you would do circuitry first before you touch programming. If you're having relatively short units that, let's say, students are only going to have a 10 to 15 hour experience, you may want to look at using a software like Scratch, where almost nothing ever goes wrong. You drag a set of blocks and it compiles and produces an output and gives them very useful feedback all the time. So I'll give you a couple of examples of that meet all of those. So I created a program called Pokemon Probability. So this is actually a math-based game written in Python using Turtle. I've done a Turtle version and I've done a Pygame version where a Pokemon spawns at a location on a grid depending on an algebraic equation. So this covers algebra all the way from years 6 through 8 because they actually have to understand and graph equations. It covers all of the, like 5 out of the 10 digital technologies curriculum in 7 to 8. And it's a game where you compete against your friends in order to catch the most Pokemon. And I did this at the time that Pokemon Go was a hit. So you kind of have a cross-curriculum, 2 subjects meeting each other, ticking all the dots. All the kids are playing Pokemon Go at the time. And, you know, there's a systematic way to build that application. So that was one. I also did, using the same sort of cross of maths and programming, projectile motion equations. So at the time, this was a couple of years back when Angry Birds was the thing. Kids were making their own Angry Birds game. And depending on the year level, the primary years would start a Scratch program with those projectile motion equations built in. The older students would program the projectile motions equations themselves. And, you know, they would be rebuilding something that they already are familiar with and excited about.
Is there a pattern there? Are you looking around for what's hit in like the age of the children or students that you are looking to build curriculum, and then you take some, you use that as like the context within which you build something to teach mathematics, for example?
Yeah, I mean, so I guess if I wanted to give people advice in terms of how you prioritize, start with making something exciting for the students, because you'll have the teachers sold on that idea immediately. Like if the teachers thinks that my kids are going to love this, that's great. You have their attention. And at that point, the teacher just wants to know, okay, so show me how this is going to teach them what you said it's going to teach them. So I think that the starting point is an interesting theme and something that that is engaging to the student. I'll give you a simple example of like one single tutorial in Arduino. You can, in about 16 lines, build a program that has a timer. In Arduino, it's, delay a millisecond that stops when you press a button. Now, that stop is either active, the start of the timer is either activated by a buzzer or by a light. And that stop measures the reaction time of the student in milliseconds. That is cool. When kids see that, when you demonstrate it before you go ahead to build it with them, they want to build their own and they want to measure their reaction time. And it's a kind of interesting question that you can expand into science and why we react better to sound or light. But to build it, you actually have to create variables, you have to iterate them, you have to use the loop, you have to write some if statements that freeze it. And you have an opportunity to expand that into doing some, basic data analysis with calculating your averages, best times, worst times, saving the results in an array. And I actually do this. I do this with both the reaction time program with both like Arduino and Python. So that, the Pokemon probability and projectile motion were like bigger multi-lesson, like 10 lesson projects. Whereas, that reaction time is a one lesson example where that really is at play.
Yeah, and that's something that you'd say that most kids beginning with either the Raspberry Pi in Python or the Arduino will be able to handle fairly early in the learning process?
Oh, the reaction time circuit, yes. Yes. I mean, I'm off to Canberra tomorrow, and I'm having an Arduino class, and I'll tell you like what this is in one day, this is what the kids are going to be doing. So this is themed Electro Gadgeteer, and we're going to watch a set of videos about Cutler and James Clerk Maxwell, who kind of invented the RGB system. So they'll start off warming up with circuits, just learning how to use LEDs, resistors, and buttons. At this point, they'll blink one LED, and they will discover at what blink rate they can no longer perceive the blinking, which is real world information, which tells you, hey, it's the same thing as the refresh rate of those screens there. It's about, 40 to 60 blinks per second. At which point they watch some videos, as like a BBC documentary about Maxwell, the discovery, first of all, Thomas Young hypothesizing that if painters can mix red, blue, and yellow to make any color in the world, that there could be something about the human eyes that we can only perceive three colors, that we mix them together. So they build an RGB blinker that blinks red, green, blue, red, green, blue, red, green, blue, and witness that mix into white. If there's time, they build a color mixer, and they also build the reaction time device. So it's sort of really themed to tie in together with human perception. The human reaction time is, well, where does that time go? How does sound compare with light? Obviously, the color is, you record. I use my phone to show them that when they're seeing white, it's actually red, green, then blue. Like red, and then it turns off. So I just get a blink to go first red, then green, then blue. And they sort of realize, oh my God, like there are certain limitations to my eyes and my senses fool me all the time. And if things happen too fast, then I perceive these three things as just one.
So you get to talk a lot about perception, like human perception and how the brain interprets those visual signals. Do you get to talk about physics as well?
Not so much.
Right. So you keep it to the engineering, the mix and the colors.
Yeah. It's more like, it's human perception, rods, cones, how your eyes work, how your brain basically takes all of those inputs and puts them together into something that makes sense, and sort of the natural speed limits, like, the number of blinks per second that you can perceive. And also, for example, the 70% of your brain actually puts together your three-dimensional reality. 70% of your brain is involved in vision. And it's something like 2% for hearing. Hence, the circuits in your brain, that process the hearing produce a result that goes, to the central operator way, way quicker than the ones that do with vision, which is why, we start 100-meter races with a gun, not the green light. The only reason they don't use guns in Formula One is because, the engines are so loud. Mm-hmm. So there you go. Interesting fact.
Yeah, I always wondered. Sanjin, I'd like to ask you about gifted and talented education, because I know that you're doing a bit of work there. What's special about gifted and talented education, especially when it comes to developing curricula? What's different there?
I'll tell you one difference. I mean, there's nothing special about it. There's intelligence is a scale, and it just keeps going and going and going. So, some kids are just very smart and they learn a bit quicker. The difference, when you have very smart kids who pick, first of all, the way it works with Gateways is, number one, they get selected by their teachers. They get nominated for programs. Their parents actually have to pay for the programs, but the kids select. They have a huge array of programs to select, and they come to yours. So you get really smart kids that really want to be there. So you can take a much more adventurous approach. And you do not, like your standard lesson, the way a standard lesson works best is that you literally show your students an outcome. This is what we're going to do. Here it is. We're going to finish it in the next hour. And are you with me? Let's go. With gifted and talented students, I suppose that can work a bit more different. You present things much more in an open-ended way. It's not that we're trying to meet this particular one outcome. I'm going to show you how to use a bunch of tools, and you guys are going to create your own variations, and we're going to go crazy. I don't know what we're going to build today. Actually, that's what excites these kids. This notion of we're going to be playing with really cool toys, and no one knows what in the world we're going to build. So they're more driven by a sense of wonder and an open-ended sense of possibilities rather than achieving that kind of one defined but cool outcome.
Right.
I hope that makes sense.
So from what I've read, because I'm doing a bit of reading on the topic and on the topic of intelligence, and it seems like people with higher IQ are essentially faster learners. It doesn't guarantee outcomes, but it does seem to mean that people with a higher IQ can learn faster. And from an educator's point of view, I think that means that you can cover more content faster and therefore have a lot of time for a bit of exploration towards the end, which I think this is what you're talking about, having open-ended results, right?
I would say the single biggest factor in terms of how much your average student is going to learn in a lesson is a sense of intrinsic motivation. I mean, how curious they are, how much they really want to learn on that particular topic is, to me, probably even more important than intelligence. But, the kids that I get have both, exceptional intelligence and they're exceptionally motivated. But yes, the rates at which they learn. I mean, what I cover with Gateways with 5-6 students is typically about 25% more than I would cover with mainstream students in years 7 to 8.
Exactly.
So
yeah, the speed is amazing.
Yeah. And again, even with Gateways, I mean, there's some challenges. Not every selected kid really, I have to say, not every selected kid deserves to be there. The teachers get it right about 80% of the time. And, sometimes kids can get a bit traumatized. Imagine you're the smartest kid in your class and you go somewhere and there's 10 other kids and you think you're good at programming, and then there's 10 other kids that are flying ahead of you. Your average 12-year-old, and not all of them process it all that well.
Yes, you need to show character in those cases.
I really like putting students in groups. Initially, first lesson, I always partnered them up. So it's always like a weed. It's not an individual race. If anything, it's a race of me and my group against another group.
Collaboration.
And so they relax a little bit more that way. Second, I really make a point after a while, let's stop and see what everybody did. Let's share ideas. And if some kid really, really flies ahead, I kind of give them an opportunity to demonstrate that to a class. So I upload their file into my computer and I get them to talk through the program. And I do use a lot tools like Google Drive to just, give students a link so they can access other students' work. And the method of pedagogy there is I try to give them a feeling of hey, we are here doing something cool and unusual, and we are all sharing in that endeavor. And so I think that really, helps them also
right.
Psychologically.
It's not a competition.
Enjoy it more because, especially boys of that age can get really quite competitive, which isn't bad, but it can ruin the group dynamic.
Must control it, yeah. Got any big challenges at the moment that you're facing?
Well, with G.A.T.E.WAYS, they're looking to roll out online programs. So I'm working with them to set that up. We've just trialed a country school. So I've done one of my programs in Python online and spent 4 sessions using Zoom, actually. Mm-hmm. Using Zoom and REPL. Have you ever used REPL?
No. Have you, Marcus?
If you're using Python, it's the best thing out there. So it's basically programming in the browser. But yeah, so I'm looking to roll out to do what I do in terms of live, in-person, interactive teaching.
Right. So it's not pre-recorded, right? You use Zoom to deliver a lesson to kids, say, in rural areas. But it is live. You are interacting live with them.
Absolutely. And you're basically, they're sharing screens, you're seeing their code, you're kind of even, you can hijack their computer and correct their bugs and, comment on their code live as they're doing it.
Great. Tele-education. It's like telemedicine.
Yeah. So that's a project. And I've also committed to about 8 lessons of teaching microbit, and I have not yet really spent more than 2 hours with a microbit. So that's going to be interesting. Awesome. I mean, especially since I won't have much time as I'm going on holiday on the 5th of July. So that's what's right in front of me right now.
All right. That's great. Is it time for...
Oh dear, here we go.
Rapid fire questions.
Why not? So the first question off the rank is, well, who has been the most influential in shaping the way you teach?
Ooh.
This is a deep one. Give it your best shot.
Yeah, there has been a few influences. I'll give you one example. There's a guy called Colin Chapman at Caroline Chisholm College here in Melbourne. He's kind of famous. He's writing the National Systems Engineering curriculum. And I went to visit him in his school. So I know him from G.A.T.E.WAYS. He does G.A.T.E.WAYS on and off. So I've met him at a few of the G.A.T.E.WAYS events. But I went to his class and I saw students in groups of 4 just working away on projects. And Colin was doing next to no interaction. And these kids all had their fundamentals down. At this point, they were basically, doing their own thing. And it's student-led learning.
So what was Colin doing? Was he checking his Facebook feed, posting Twitter?
Oh, him and I were just talking about pedagogy and then what it is he's doing. But he had his back turned to his whole class and then they were just working away. So I'd never seen that in my whole life. Now, in terms of influences, you're asking me I've had really good mentors that have taught me how to teach. But this guy just showed me what is possible. And to be honest, when you see it, you believe that it's possible and that you too can do it. And then I've been getting information from him a lot. And another person was my second teaching mentor out of uni. His name is Buck Darman. And, this guy was more of a pedagogical influence. And then he worked in Keysborough, which is sort of, I'd say, a dodgier suburb of Melbourne. And he really had an authority with kids without being rough or mean or, imposing his will at all. He had a certain way of speaking and confidence that I tried to imitate to the best of my ability. It's hard to put it into words, but yeah, so he was a mentor of mine and he was a big influence.
Great, thank you. Let's talk about applications. Are there any applications like Evernote and things like that keep you super organized and productive and on task?
Kanban Flow is
really?
my...
Looking at it right now.
Yeah, I'm looking at mine right now. Yes.
Yeah. So I use both the 25-second Pomodoro, 25-minute Pomodoro thing, and I've customized mine to the max, and I've got my lists of what to do tomorrow, do today, 7 days ahead, 30 days ahead, and then I got ideas. So
and why are you talking Italian with tomatoes and stuff? What's all this about?
The Pomodoro method is this idea that you sort of work in 25-minute bursts with 5-minute breaks. I think it's pretty good. Like if I'm in the zone, if I'm working really well, I begin to ignore it because I'm just flying. But like if you're not having the best of days, you're going to go, no, I'm going to hammer away at this task for 25 minutes. Then I'm going to walk around, stretch out, sip some tea.
Yes.
And then I'll do it again. It's actually really good to keep you disciplined and organized.
Sure.
And the app itself, Kanban Flow, kind of also keeps track how much time you spend on certain projects.
Statistics.
So it really saves me because I do have to do a lot of boring things. I mean, the developing curriculum is halfway cool stuff because you just play around until something works, but then you got to write documents. You have to write a lot of invoices, correspond a lot by email, and that's where I set up my daily to-do lists and reminders.
Awesome. I've got to say, I've been using Kanban for about a year now, and it's changed the way that I work. I've always been productive, but now I actually know what I'm working on exactly like days before I actually work on it. So Kanban Flow is one of the many applications that are built around the Kanban idea, which I encourage everybody to have a look at. It's a system of cards and swim lanes, and it allows you to decide beforehand, break a project into smaller components, and then put those cards into the appropriate,
Can I ask you a couple of questions? Because, when things go wrong with Kanban, when you have an unproductive day, like, what are some of the things that get in the way?
In my case, kids.
Yeah, those children get in the way.
Einstein, my dog, will come and ask for a walk, and I have to take him for a walk.
Seriously?
Yes.
You're under the dog's paw thumb.
He'll come, get on his rear feet and touch me with his front fin and stuff, on my shoulder, especially taking it. And I'll push him away. I'm working now, Einstein, leave me alone. I'll come back again like a few seconds later. And if he comes in 3 or 4 times, then I know that he really needs to go for a walk or something. Anyway, it's kind of a half joke, things like that. But, with the Kanban, what I really like about it is if I have to take Einstein out for a walk or if I have to deal with kids, I come back. All I've got to do is to look at what is in my in-progress lane, and I can just get back into context immediately. I don't have to try to remember, where was I? What was I doing? Right? And same thing in the morning. Like I get up in the morning and sit in front of the computer. I turn on the monitor that displays constantly Kanban Flow. This is a monitor dedicated to Kanban, and I can switch on and start working immediately. I don't have to.
Computer, by the looks of it.
How many monitors do you have over there?
I've got 3 monitors. One is for Kanban only, and the other 2 are doing different things depending on what I'm working on.
I got 2. I think I need a third one for Kanban too. So
yeah, Kanban should be always displayed. There's a paper version that you can have it on paper, or it could be a white, like a whiteboard. I prefer a
I'll tell you the thing that gets me is I do the to-do list for the day before, which is brilliant. But when something comes up that makes your to-do today impossible, like another job or an emergency or a phone call, or maybe one of the projects kind of blows out, then I can't meet my goal for the day, and then I'm less productive because I can't get that high at the end of the day of having crushed it. So I do
on that. It's quite, now we're talking about Kanban, but I think it's very interesting.
You guys are all like Melbourne man today.
So what I do, like I've got my standard calendar schedule. Like, for example, now I'm writing a book and I've got 3 days of the week, which is specifically allocated to writing a book. Nothing else will fit in it. But, things happen. I get an email in the morning from like a student, and he's asking for something that seems to be a broken link, for example. It could be more substantial, like a bug found in one of my videos I've got to fix. So before I do anything, I have to put it in my Kanban flow. So I might just skip it to the top of the do-today list, for example, and put everything else below it and push everything else below it. So that is allowed, but only allowed for emergencies. So luckily, I don't have that many emergencies other than kids and Einstein. So my Kanban flow actually flows, but emergencies do happen, and I'm always mindful and allow them. The thing is that no tasks are left undone. Once I deal with that emergency, I'm going back to my normal Kanban flow and just continue from there. And what I want to see is that my done column at the end of my Kanban board, that has to be pretty busy by the end of the day. And that tells me how productive and successful my day was. And I can
just one last question for you. Are you like one of those? Would you say that if you have 3 good days, you're more likely to have a 4th good one, or you're more likely to bounce back from a bad day with a good one? Like,
no.
Do you carry momentum, or do you bounce back more generally?
Yes, look, I'm like a machine when I work. Yes. I don't have bad days unless something external happens. Like I have to be in a conference, for example, and that day I count it as non-productive because my Kanban flow is empty. My done list is empty. Psychologically, it is good, and I do like meeting people. Like when I met you at G.A.T.E.WAYS, that was a very unproductive day, but it was a very good day nonetheless. And last week I went to the P-STEM Expo. And I met some really interesting people, but I didn't get anything done that day. And still, that was a super good day, but very unproductive. So I'm happy with that. But I've got to say, the day after, so I went to P-STEM on Tuesday, totally unproductive. The day after, Wednesday, I was so energized that my done column in my Kanban screen overflowed to the bottom. So I had about 15 done items there. It was, wow, that's very unusual for me for a single day. So
cool.
There you go.
Thanks.
Yep, anytime. Let's see, I'd like to ask you one more. Actually, Marcus, you do the honors. One more rapid fire question.
I would like to ask the question that is highlighted.
Which one?
Well, how do you boost your confidence in teaching STEM subjects?
How do you... Man,
are you confident?
How do you boost your confidence? Okay, I gotta go back to the time when I lacked it. I mean,
Okay,
I'm in luck. I'm in luck. There was only one situation that perhaps, in my field, a lot of people that teach it, I'd say 75% don't even have, engineering qualifications. So
75%, you're being so generous.
I am already, maybe I'm generous. So I already feel like given the experience of the last few years and also the technical expertise, like I always feel pretty confident in my ability. But, sometimes that's not the case. I had a training day about 2 months back that was for DLTV, and it was in object-oriented programming. And I asked people how many people here have like an engineering background, and it was, I think, 12 in the workshop, 11 put their hand up.
Cool.
And how many people have taught object-oriented programming, and 5 put their hand up. And I'm like, okay, I'm behind 5 people attending my workshop. What in the world are we going to do? But fortunately, they liked the creativity. Like I came up with this idea of a simple Python object-oriented it was like a fighter game, and you were, a fighter adventure game, and you were killing monsters, and you were getting your attributes upgraded. And they thought that
it was fun.
That was a good idea. I thought it was fun. Yeah. But genuinely, I mean, I was nervous. I stammered a few times, but I just had faith that, all I need to deliver is one of many aspects of this workshop, like a good creative idea that they can take back to class. would be more than enough. I don't necessarily have to know more than my audience. I just have to deliver something that they find valuable. And I think that, you know, for a lot of teachers that are out there with kids that know more than them, like, we all have something in common, that what we don't know is hundreds of times bigger than what we do know. So can you find something valuable you can deliver to your audience? And the answer to that is usually yes. And then that's kind of what you lean on.
That's good advice. Any parting thoughts for our listeners? And yeah, like, let's say that our listeners consist of new STEM teachers, so perhaps new graduates of a teaching school. What advice would you give them?
If you had to put this advice on a billboard, what would that billboard say?
Okay. Very, very sort of practical stuff. What you want to do is you want to have short learning units. You don't ever want to continue with one particular, say, Python or Arduino. You don't want to continue beyond 10 lessons. You want to start from scratch 3-4 times per semester. The reason for that is you don't yet have enough knowledge to basically build 6 months worth of stuff. And your students are not going to get it the first time anyway. So if you can find creative ways to teach those same core concepts using different technologies, it will be like looking at the same building from 5 different perspectives. You know, you're going to understand them better, and you're going to spend more of your time in your comfort zone than if you try to first time around deliver 25 lessons worth of a particular platform, be that Python, Arduino, Vex, Microbit, you know, from fundamentals to advanced concepts. So I would say first time around, in a self-contained sub 10 lesson way, start from beginning multiple times and do it that way. I would also say you're going to be in a situation where your kids know more than you, and that's okay, because you're going to be in that situation 10 years from now when you're an expert, because there is so much to learn in this field that if your kids actively go online, they probably are looking at libraries that you haven't yet seen that do things that you're not yet aware of. So that's something you just kind of get used to. Yeah. And you try to build a sense of joint purpose between you and your class, that we are trying to do something cool and interesting together, and it's going to take participation from everybody, and we're going to get, you know, you should be open to your students' ideas. Yeah. And try to finally, whether that's one lesson or whether that's a learning sequence, try to always break things down into structured and open-ended. And depending on the type of your students, depending on the type of person you are, that balance may come in different places. You know, in my case, I'm pretty much a 50-50, 50% structured, 50% open-ended. But, you know, I think that it's essential to have both in a good STEM lesson, and that you find your own balance to how much of which you apply.
Yeah. Well, thank you. I'm reminded of your advice almost every day that, you know, you will never know everything, by my students who will always remind me how much or how little I know. So that's great advice, especially when you're getting started and you think that you don't know too much, which is actually normal. It's good. Well, thank you, Sanjin.
Yes, thank you.
I really appreciate your time and having this really interesting conversation. We covered quite a lot of topics, like even Kanban. So
you're very welcome, guys. You're very welcome, guys. I think it took us like half an hour to warm up, but it was really fun. It was awesome by the end of it.
So hope to see you in Sydney. And
yes, definitely.
We'll definitely talk before then. I've enrolled to one of your subjects. I enrolled to your Scratch subject.
Oh,
you've got a Scratch lesson, I think series of lessons on your website. So I've enrolled it because I'm teaching Leo, my son, and Ari, both of them. I'm teaching them how to do Minecraft modding using Scratch. I'm using Tinker.
Cool.
But your what I like about your video course is that it's a bit faster than the Tinker Minecraft course is. It takes 2 or 3 days just to do a for loop, because they use it while they're building something in Minecraft. So you got to go constantly back into Minecraft, see what the mod does, and go back to tinker and make another modification and all that. So it's a bit faster, but it's really nice work.
I would, I'm just doing one with Scratch, actually. We call it's the zombie apocalypse, and the kids make like a tower defense style game to kill I think, how old are your kids though? Maybe they're not going to like the idea of killing a lot of zombies.
No, I think they will.
There's no problem.
We've got zombies covered.
Actually, Leo's avatar is a zombie.
No doubt.
Well, I haven't created a set of videos, but I've got like a sequence of programs of how that game builds. If you want, I can send you that.
Sure,
maybe you can retheme it.
I'll try it on them.
If that works. Yeah. But okay. All right. Thank you, guys.
Thank you, Sanjin. It's been awesome. Talk to you next week.
Thanks, mate. See you. Bye.
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 That's all for this episode. The notes for this episode that include links to many of the resources mentioned and information on how to get in touch with Sanjin are available on our website, techexplorations.com/p/Stemiverse. Each episode comes with its own page on the Tech Explorations website and a goldmine of information in the notes. This Stemiverse podcast episode was produced by Tech Explorations. Do you have any questions or suggestions? Would you like to nominate a friend or colleague to be our guest? Please email us at pa@texplore.com. Subscribe to us on iTunes by searching for the name of our podcast, Stemiverse. That's STEMIVERSE. Thanks for listening, and we'll see you again next time.